My name is Łukasz, and I will try to answer the question at least the way, give you an answer that I discovered actually over the years about how much of the upfront design or architecture or any actually preparation you would like to do before you start implementing while you are still having developing with an agile team. And this is going to be a talk by example, so I'll give you the answer right away. And I believe the answer is enough that your team understands what they are actually about to build. And I know this is a vague question, and of course the actual amount of preparation depends on what you're building. But I found that this is more or less a middle ground, because I went back and forth. I started dealing with agile practices in 2002, and we jumped straight to extreme programming, and we were doing it really extremely. At the same time, I was working at Philips Research in Netherlands, and I was there basically at the beginning training and then acting as a system architect. So a guy who is responsible for, drawing all the big boxes and making sure that everything would work in the end if you made it in a waterfall way. So I went back and forth, and I think this is basically the middle ground that I think it holds in most of the cases. And that also means that if you are building a product that you understand completely, especially if you are if your business is about building something very repetitive, there are certain classes of web applications, for example, and businesses around it. You just deliver, roughly the same software over and over again, just, changing it slightly. And in this case, I would actually agree with the people who say that if you do agile, you don't do any upfront design. On the other hand, the example that I'm going to show you in a second is about building a completely new product in a very unusual circumstances, at least for us. And we did some upfront preparation, quite a lot of it actually. And it worked for us, even though our development process was completely agile. I don't see a contradiction in terms here. So just first to give you a little bit of a background, because this is important that I try to show you, how complex the situation was for us. So we have to go back to the year 2005, and we are at Philips Research. Philips at the time is a really big consumer electronics company. By now, they are not probably anymore, but at still the time we were really strong. And we are building a portable video player. It will be a little bit special video player, and I will explain it in a second. But this is how in 2005 the market of the portable video players looked like. So the iPod just got a color screen in the autumn of 2004. It won't be able to play video until late in 2005. And actually most of the devices that start showing on the market look like the Arcos here, with one huge exception, and that's the PlayStation Portable, which came out just a few months before we started. And it was, at that time, for us, their bigger competition that was mind-blowing, basically. So this one is a misrepresentation. So this actually, we couldn't get our hands on it. Definitely we couldn't, see what's inside. So we are in the era of basically this kind of devices. And on the business side, again, the background of this project is we are a consumer electronics company. And this is one of the few, maybe not few, but there are not many niches where your business is very much aligned with the happiness of your customers. And being a hardware manufacturer, especially for that goes directly to consumers, this is basically, you have basically one-to-one alignment with your customers. And, but the video is something that is owned mostly by, roughly speaking, Hollywood, and they have completely different view of their customers, so people who actually do consume movies, and they basically think that there is that the ratio of people who want to steal the content or get the video without paying is big enough to threaten their business, and because of that, Hollywood was actually ready to compromise the experience of users and make them go back to the 50s and basically have this model that you have one device that can render the content and everybody has to sit around it. which was quite the opposite to what we wanted. We wanted to have, any content, anytime, anywhere. And in 2005, it wasn't that obvious that whether it was going to happen. So basically, the bottom line, the underlying story of this project is how can we build a whole system that would support playing digital video content that would be downloadable, that you could stream, that you could pretty much do anything with that you would do with a physical DVD. Because from the user perspective or the consumer, that was the real problem. Both Hollywood and consumer companies like us were trying to convince them that once you don't have the content bound to a physical medium, it will be the completely new world for you as a consumer. But on the other hand, if we put all the restrictions in, you could do less with your content than if you bought a DVD. That was clearly pointless, right? So this is where the first part of the upfront design started for us. We are still probably a month or maybe a month and a half from actually even forming the Agile team. And we started thinking about scenarios. So what is that we want our system to be able to do? And here you see basically the setup of the whole demo. So we had a number of devices. Some of them were portable. Some of them would be fixed at home, like TVs. You would have a home server. There would be, it's actually not represented here, but it would be a whole basically back office, making sure that you can buy a movie, that you can download it, that you can stream it. And if we wanted to do everything with the content that you could do with a DVD, we have to introduce a notion of users, and then devices would be connected to users. Users could be grouped like in a family, because there is no reason that if father buys a movie that the whole family wouldn't be able to watch it. That would be nonsense, right? And we have also scenarios like visiting someone's home, and here, like little John was moving to live with his girlfriend, and now he, of course, would like to take all his content that he paid for with him. So first step of the upfront design is actually figure out your scenarios, and it very much clarifies what are you going to build. This is also what Marek said, not to build the thing you don't need. And I think this is a mandatory step, and you cannot go bad without taking this step. So once we knew what we wanted to build, there were two of us who were both architects, and we knew how to build the system in the back that would make it possible that you could enjoy your content anytime, anywhere, but without violating what Hollywood wanted and without violating the rights that you got when you purchased the movie. And we went through the pretty standard procedure of partitioning the system, figuring out the dependencies, the hierarchy. We didn't go as far as a class hierarchy, but we had it really figured out how the system should be partitioned, how the functionality should be split between different devices, backend services, and so on. And then we felt kind of proud about this, but we are still not completely happy, and this was for two reasons. And the first reason was that we were not sure whether we have missed something big that would show up only later in the development process and basically take us back to the drawing board. And the second thing that was more of a feeling that got confirmed later on, that we were not sure if this kind of pictures will be good in explaining to the development team actually what we really want. Because the big part of the puzzle that we had to solve was in the heads of two people, and this was this DRM stuff that was managing all the security issues, and they had to add to this basically things like applications, streaming, getting content from A to B. We were just not sure whether this kind of image would resonate in their heads well enough, so they would actually could commit and understand what we want to build. So we decided to take it a step further, and I have to apologize for this crowded screenshot, but it's the only one that I have left from 2005, and I will go with you step by step through it in a second. But basically, this was the step that proven in the retrospect to be really critical, and this is where we decided to model actually the behavior of the system. So from this moment on, we are not so concerned about, the exact dependencies, but actually we were concerned in figuring out how all these different bits and pieces and moving parts, how they actually exactly work together. So this was a three-step approach, and it was a little bit enforced on us by the tool that we are using, and this is, by the way, a tool taken from a university, and it was developed there for a completely different reason, but it looked basically useful to us. So on one level, we have modeled basically the big parts of the system. So the blue square that you see here is basically a portable device. And the stuff around it are all kind of different, either big software modules or maybe some servers or services. And the lines that connect them, this is basically where the information will be flowing from one, box to another box. And then again, we took it a step deeper. So what you see now there in the corner is the inside of that blue box. So we are not happy enough to show the team, this is the portable device and this is how it will be communicated with the other services. We took it a step further and we also modeled what's going inside of this, for example, in this case, this mobile device, but we also modeled services and servers and pretty much all the other applications that way. And then inside of each of these boxes, basically, we wrote some code. And this is also a critical part because what we have implemented in this model was not the actual guts and the mechanism and the algorithm inside of all these boxes, but we have implemented basically how the message passing, how the communication pattern look like. So the code inside of each box basically waits for a certain message, and if certain message comes, it sends a different message, right? So basically, once we click run on this thing, and this was an executable model, we had basically the whole system already operational, but it wasn't actually doing anything. So it wasn't able to play video or anything like this. But you see how all the bits and pieces work together. And we thought that that would be basically the best thing to show to the development team, because that code that was sitting inside of these boxes was showing basically what kind of information each particular software module expected, how it would react to each of them, and also which stuff was basically happening in parallel and which one was basically sequential code, which was quite difficult otherwise. But it turned out that we were wrong. And actually, the most useful part of this exercise was an artifact that was generated by this model once we ran it. And it was basically a message sequence chart that shows all this interaction in time. So that was a big discovery for us. And then actually, we printed this message sequence charts. We had, I think, 4 or 5 of them. We printed them really big and hung them on the wall. And then we spent really hours discussing, and explaining why we think that, the messages go in that order and not the other order, how does that particular scenario flow through this system. And why it was a good idea? Because once we started development, because only now we have a team and we start actually coding, the first step that we did was we built what is called a walking skeleton. I don't think this is a very common term. Does anyone heard about it before? Okay. And I know there is also another talk, I think tomorrow, that has a walking skeleton in the title. I'm not sure whether this is the same story, but basically what we did is we took this model and we were fairly sure that it is exactly how the system should work because we actually generated those messages. So we had a big chance to be right. And basically during the first 2 or 3 iterations, we have implemented basically the whole system from the beginning to the end. Again, just like this model, the system wasn't doing anything. I mean, you couldn't really buy the video or play it or transfer it. But we have all basically bits and pieces already implemented, and the communication between them working properly. So I would argue the whole system was working properly. We knew that. And actually, it has a number of advantages. And the biggest of them was that we kind of did the integration as the very first step. So we hit a number of, actually this project took 2 years and we had many ups and downs, but none of them was actually about integration. So this is something that I would really hardly recommend at least trying. And, but we still had one problem in front of us. So once we had this model, we started basically filling in, iteration after iteration, we started filling in the functionality. So we knew that, basically everything that was hidden from the user, so everything that had to be done for the video to render or not to render if it wasn't allowed, was working perfectly, but we didn't have the user interface. And for the reason that we couldn't find a hardware platform that would basically, that we could build the portable player on. So this is the part that of the design that we didn't do upfront, mainly not so much the user interface, but the interaction. And actually that hit us pretty hard once we found the hardware that was suitable for us. Surprisingly enough, we found it in a sister lab in Belgium, and they were developing this product for a completely different purpose, completely different customer. But we could put a network card in it, and it was capable of playing video. It had hardware acceleration, and it was running Linux, and that's all that we needed. But unfortunately, we're also constrained with the form factor. And we have, you can hardly see it, but we have 5 buttons at the bottom, 3 on the right-hand side, and a joystick on the left. And that was it. So now we had to figure out, how this device could be, used in order to, for the user, to make it possible for the user to do all these scenarios that we thought of. And the scenarios were, as you saw, were pretty complex because we had things like assigning devices to people, assigning people to groups, moving people between the groups. We had video download, video streaming. It was actually quite a complex interaction that had to be basically designed from the scratch. And then we decided to take it on a kind of a parallel activity. And very much like this executable model that I have shown you before, we made basically a mock-up that allowed the user basically using all these controls, and that would be able, and our users would be able to play all the scenarios using basically just these buttons. But the problem was that we did it, and it wasn't playing here. Again, we would fake the actual internal algorithms and the difficult stuff. So instead of showing a video, we would show basically a picture. But again, that was simplification. But we didn't go as far as, no, let me rephrase it. That was a solution good enough, basically, to design the interaction. The problem was that we had no chance to do this upfront, and once we got our hands on this one, we figured out, how to make these different scenarios. Then we realized that we have to change a little bit of our, already built infrastructure, and it's not actually that we had to change it drastically, but only when we looked at the interaction with the device, we figured out that, not all the scenarios could be played out in a way that we thought they would, because I think the example, the most painful example there was that we thought that the user would always start from purchasing a piece of content and you could do anything with this. And I think when we gave it to real people, they found a way that they would like to start, for example, with an intent. So, for example, I would like to share the video with, with someone, and only then I realized I didn't have the right content, or I didn't have the rights to stream this video to someone else. So it's shaken the scenarios a little bit. And the reason why I'm saying that should be done upfront, because actually I don't feel bad about not thinking about all these alternative scenarios, because I simply believe that it's just impossible. So basically, just to summarize, what we figured out was the right amount of the upfront design for us in this particular system. So the composition and the partitioning of, no, let me start from the scenarios. The scenarios were definitely a good idea because it basically narrowed down the scope of what we were supposed to build, and gave us really a focus, so we didn't have to deal with all the problems in the world basically, but only those that were covered by the scenarios. Then from the static analysis that we did, the static architecture, whatever we call it, the kind of the big decomposition into, what are the big blocks, what are the big services, what goes on which device, that was fine, that was useful. But the more detailed levels, like the dependencies and relations, we did this. We spent a lot of time on this, on that, and we never used it. So that was probably a step too far. But this decomposition actually, together with scenarios, did inform the behavior. So the model that I showed you, and all those message sequence charts that were absolutely critical for our success, that was definitely a good idea. Building a walking skeleton, excellent idea. I would do this, even if I didn't have the behavior. I think it's a really nice way to make sure that you avoid many of the reefs later on, even if you don't know that the reefs are there. And finally, in our case, the interaction user interface was done, in parallel quite late. Maybe not halfway through the project, but like 1/3 into it. And that was too late. If we had the hardware, actually, even if we didn't have the hardware, if we knew how the hardware would look like upfront, it would probably shaved off like probably a month of execution over like 2 years scale. So if I had to narrow it down to 3 takeaways, and as I've shown you, this project taken place in 2005, we are 2014, I really still draw from what we have learned during this project, is that if you have to explain some technical, non-trivial technical solution that you have, in your head, it seems that it's way easier to explain the behavior of it instead of, just the static kind of view on it. The other one is, I already said it more than once, this walking skeleton, a really good idea, if only for the avoiding of the integration at the end. But it also, again, focuses you on what you should be doing, and also you can track progress against the walking skeleton much better, because you see how you are filling in those empty blocks with real functionality, and then you know really where the end is. And if you start delivering functionality after functionality, it is possible that you might have missed something big, and you thought you would be, even with your perfect burn-down charts, you think you will be ready in a month, only to discover, oh, we forgot something. And this and the last point is something that is not so difficult to convey to people these days, but the interaction with your system has to be designed like everything else. I know the teams are still quite often struggling with having the designers assigned only at the very end of the project, but I see it definitely changing. So if you have any influence over when to involve designers, invite them at the very beginning, because you will end up, first of all, building a better system. And there is a big chance that you will build a system that is smaller that you think you would need actually.